Don't get tricked into using trig substitution. So in this integral, like mainly what people see is there are signs in the integrand, there are pi's in the limits of integration. So they feel like using a trig subs, let's say u is cosine square x might help, but try that, it just complicates this stuff. Yeah, so what could be better is uh, using partial fractions. So over here, if you look at it in the following way, let's say if you look at it as 1 by a plus 1, a plus 2, where a is sine square x, you can break this into partial fractions, right? And after you break it to partial fractions, there will just be one denominator, like just either a or a plus 1, and then it will be easier to deal with. Yeah, when you don't have productive signs, maybe it's easier to deal with. Yeah, but at least it will be simpler than what we have right now. So let's do that. You can either use let's say cover up rule or any other standard way to break this to partial fractions, but I will use the following way. I will introduce a plus 1 minus a in numerator first, right? And after that, if I cancel with a plus 1, I will get a plus 2. Over here I get 1 by a plus 1, a plus 2, right? Again, I will introduce something in the numerator. This is half of a plus 2 minus a divided by a plus 2, because the a cancels out and 2 remains, so I need to introduce a half over here. Over here this is a plus 2 minus a plus 1 by a plus 1, a plus 2. So this is 1 by 2 divided by a minus 1 by 2 divided by a plus 2 minus 1 by a plus 1 plus 1 by a plus 2, right? So this is half divided by a minus 1 by a plus 1 plus half divided by a plus 2, right? Okay, so we have this partial fraction decomposition for this rational function, right? Now using this, let's try to decompose the given integral. Integral from pi by 4 to pi by 2 of 1 by sine square x plus 1 sine square x plus 2 dx. This will be equal to integral from pi by 4 to pi by 2 of 1 by sorry I will just erase this. I don't need this long denominator actually. Okay, now this will be equals to, first of all, half by a is our sine square x, and minus 1 by sine square x plus 1, and then again half by sine square x plus 2 dx. So now I think everyone can do this, right? Now we can break this into 3 integrals, and all of them are easy. Really easy, in fact, not just easy, really easy. Yeah. Now I will still solve it for the sake of completion, but yeah, I think you should give it this a try before you watch the solution. Yeah. Okay, now let's try to solve it. So for this one, what we can do is half of pi by 4 to pi by 2. This will be cosec square x dx, and we know that integral of cosec square x is minus cot x from pi by 4 to pi by 2. Cot x 8 pi by 2 is 0, minus 8 pi by 4 it's minus 1, so that's half, right? Good. Now for the next one, also notice that there's a minus sign, please don't forget that. But first of all, let's just do the integral. Let's do it with the minus sign so that it will be easier later on. Now what, how we can solve this is change 1 as sine square x plus cos square x. Yeah. Now this will be 1 by this dx 2 sine square x plus cos square x, right? Now divide both numerator and denominator by cos square x. So that will be sec square x dx by 2 tan square x plus 1. Now make a u-substitution that u is tan x. That gives us from 1 to infinity du by 2u square plus 1. Now if you integrate this, this will just be minus 1 by a tan inverse x by a, and also since there's coefficient of x, I have to write it like this. This goes from 1 to infinity. So this is minus 1 by root 2. At infinity it's pi by 2. At 1 it's tan inverse root 2, right? So this is tan inverse root 2 by root 2 minus pi by 2 root 2. You got this, right? This is with the minus sign again. This is with the minus sign. Now we have the third integral, half of sine square x plus 2, right? Third integral is integral from pi by 4 to pi by 2 half of sine square x plus 2 dx, right? You can take half out. Integral from pi by 4 to pi by 2. Now write that 2 as 2 times sine square x plus cos square x, right? So that this will be integral from pi by 4 to pi by 2 3 sine square x plus 2 cos square x dx. Now again, just like in the previous solution, multiply numerator and denominator by cos square x. So that will give me sec square x dx divided by 3 tan square x plus 2. Now if you make substitution that u is tan x, you get half from 1 to infinity of du by 3u square plus 2. Now if you integrate this, you will have half 1 by a tan inverse x by a times the inverse of the coefficient of u from 1 to infinity. So this is 1 by 2 root 6 pi by 2 minus oh wait, there should be root, right? Because a is root 2, sorry. So tan inverse root 3 by root 2. So this is basically 1 by 4 root 6 minus 1 by 2 root 6 tan inverse root 3 by 2. So now if you compile all the answers, basically this has answer half, and then tan inverse root 2 by root 2 minus pi by 2 root 2 plus pi by 4 root 6 minus 1 by 2 root 6 tan inverse of root 3 by root 2. I agree this problem was definitely long, but this wasn't hard, because after we broke it into partial fractions, there really wasn't anything to do. It was just use that same old technique and solve it, right? Just the partial fractions, you might not you might not be able to come up with that, because you might get tricked into using your substitution. But after that, it's just the same old thing, and we solve the integral. And I also have an answer here from Wolfram Alpha. Let me check with that just to make sure. The answer is, let me open the Wolfram Alpha. I guess you know that website, right? So half plus this is pi by 4 root 6, right? Minus pi by, okay, wait, now this is pi by 6 root 2 by 24, which is 2 root 2 minus pi by 2 root 2, yeah, that's right. And then minus tan inverse root 3 by root 2 divided by, that would be around 6. How much is 2 root 6 divided by 24? That's root 6 by 12, and that's 1 by 2 root 6. Yeah, that's the same thing. And plus tan inverse root 2 by root 2. Yeah. So this is correct according to Wolfram Alpha, and I know that Wolfram Alpha is never wrong. So yeah, guys, this is the answer. Just to recap, it's partial fractions and then the normal solving trig functions idea. So that was it. Hope you enjoyed the video. Thanks for watching. And also do check other videos on my channel, like maybe the one on matrix multiplication to find the nth Fibonacci number, yeah, or the some integration techniques or tricks like King's rule. I hope you will enjoy that, and I think that this YouTube will be beneficial for you. Thanks for watching. Look forward to seeing you in the upcoming videos.